Return to zero, the secret to China's aerospace success. We'll start our talk about the return to zero concept from a tragic failure. On February 15, 1996, the Long March 3B rocket made its first flight at the Xichang Satellite Launch Center in China. Just 22 seconds after taking off, it crashed into a nearby mountain, destroying both the satellite and the rocket. What's more tragic was that it led to a heavy toll, with 6 people losing their lives and 57 people being injured. An investigation after the incident showed that a tiny electronic component on the rocket malfunctioned during the launch, which then caused the imbalance of the inertial system and finally resulted in the failure of the rocket launch. Such a small mistake brought about such a huge loss. So how did China's aerospace industry deal with this situation? Well, they adopted the return to zero method. The return to zero concept includes 2 aspects: technical return to zero and management return to zero. Let's introduce them one by one. Technical return to zero. Technical return to zero refers to the process of thoroughly investigating the causes of technical problems that pop up during the research, development, testing, production, and use of aerospace products through a series of set steps and methods. Then, effective measures are taken to solve these problems and make sure that similar problems won't occur again. Here are its 5 requirements. 1. Accurate positioning. Use all kinds of testing and analysis tools to accurately locate the specific parts, links, or components where the problem lies. This is the foundation for solving the problem. For example, by closely analyzing the monitoring data of satellite failures and combining it with ground simulation tests, we can figure out that a certain electronic component on the satellite has malfunctioned, leading to abnormal signal transmission. 2. Clear mechanism. Do in-depth research on the internal physical, chemical, and electronic principles and mechanisms behind the problem. We need to understand not only what happened, but also why it happened. For instance, when it comes to a rocket engine failure, we have to figure out which part of the combustion process is abnormal, whether it's a fuel supply issue, an ignition device problem, or a structural design flaw in the combustion chamber that caused it. 3. Problem reproduction. Under the same or similar conditions, be able to make the problem reappear to verify whether the positioning and mechanism analysis of the problem are correct. This requires creating a test environment similar to the actual working conditions and conducting repeated tests to reproduce the problem. For example, we can simulate the space environment in the laboratory and test the faulty components of the spacecraft to make the failure phenomenon show up again. 4. Effective measures. Based on the causes of the problems, formulate and implement practical and effective solutions to ensure that the problems are completely solved. The measures may include repairing or replacing faulty components, modifying the design plan, and optimizing the work process. For example, if we find that the power generation efficiency of a satellite's solar panels in space is reduced, we can take measures like improving the materials of the panels, optimizing the installation angle and heat dissipation design of the panels to increase the power generation efficiency. 5. Draw lessons from one case. Promote and apply the experience and measures for solving the current problem to other similar products, systems, or links to prevent similar problems from happening again in other places. For example, if a valve on a certain model of rocket malfunctions, after solving the problem, we should conduct a comprehensive inspection and improvement on the same type of valves used on other models of rockets and spacecraft to avoid similar malfunctions. That's the content of technical return to zero. Now, let's look at management return to zero. Management return to zero is to analyze, deal with, and summarize the quality problems of aerospace products from a management perspective. Its aim is to improve the management system and processes, raise the management level and efficiency, and prevent the recurrence of problems. Here are its 5 requirements. 1. Clear process. Sort out and review the whole process of the problem occurrence, covering all aspects from the product's design, research and development, production, testing to its use. We need to clarify what happened at each stage, who was responsible, and what measures were taken so that the whole process is clear. For example, when there's a malfunction during an aerospace launch mission, we must have a detailed understanding of the specific situations at each stage, from the formulation of the rocket's design plan, the production of parts, the assembly and debugging, the ground tests, to the launch. 2. Definite responsibilities. Determine the responsibilities that each relevant department, position, and person should bear during the process of the problem arising. Make sure that the responsibilities are assigned to specific individuals to avoid the situation of passing the buck. For example, in the case of a quality problem of a certain spacecraft, we need to identify whether it was caused by design flaws in the design department, process problems in the production department, or insufficient inspection in the testing department, and then determine the specific person responsible. 3. Implementation of measures. Seriously implement all the management measures formulated for the problems into the actual work to ensure that the management work is effectively improved. These measures may include improving the management system, strengthening personnel training, optimizing work processes, and intensifying supervision and inspection. For example, after formulating a stricter product inspection system, we must ensure that the inspectors strictly follow the system and carefully examine every component. 4. Strict handling. Seriously deal with and hold accountable for any violations, breaches of discipline, or negligence that occurred during the process of the problem arising to play a warning role and enhance the sense of responsibility and quality awareness among all personnel. For example, when some staff members' negligence leads to serious quality problems in aerospace products, they should be given disciplinary sanctions and financial penalties. 5. Improvement of regulations. Revise and improve the existing rules and regulations based on the management loopholes and deficiencies exposed by the problems, making the management work more standardized, scientific, and institutionalized. For example, after a certain aerospace accident occurs, conduct a comprehensive revision of the safety management system and add requirements for risk assessment and control in some key links. Alright, that's the main content of the return to zero concept. Now let's focus on how the rocket launch failure was handled. After finding out the causes, the research and development team carried out a comprehensive review and completed 12 categories and 122 tests. They also put forward 44 items and 256 improvement measures. On August 20, 1997, the Long March 3B was launched again and achieved a complete success, reversing the passive situation of China's aerospace industry. Facts have proved that the return to zero concept can find the root causes of aerospace incidents and solve them when dealing with such incidents, ensuring the continuous and normal operation of the same model systems. For example, the return to zero concept has been applied in dealing with the failure of the escape system of the Shenzhou V manned spacecraft, the failure of the Chang'e 3 lander, and the landing impact problem of the Shenzhou I return capsule. It has successfully solved the problems and improved the overall safety level. Now, let's summarize. The return to zero concept is applicable in the following scenarios: ensuring the 100% successful operation of complex systems. Applicable in industries with extremely high safety requirements such as aerospace, rocket manufacturing and launching, aircraft manufacturing, and high-speed rail manufacturing. Correcting errors at any cost until the problems are completely resolved. The return to zero method is to completely eliminate technical hidden dangers through technical return to zero, while strictly implementing various improvement measures of management return to zero. The return to zero concept is similar to ideas like review and lean improvement. However, due to the extremely low tolerance for errors in industries such as aerospace and aircraft, the return to zero concept requires achieving a perfect solution to the problems. In the case of a rocket launch accident, according to the requirements of the return to zero concept, the current and subsequent rocket launch work should be stopped, and resources should be concentrated to find and solve the causes. Implementing the return to zero strategy is extremely costly and requires high technical and management capabilities. The overall suspension of work will cause great pressure, but it's worth it because we need to ensure long-term success and we can't rely on chance. Thank you for watching Learn Chinese Today. See you next time.